getting started. We are talking about reflections today. Overall, chapter 9 is going to go over transformations. All right, so we're doing a lot of graphing, right? We know our coordinates, plotting points on the graph. Okay, a lot of stuff that we've learned in middle school, we're bringing it back and using it here in this unit. Okay, so transformation is the operation that maps an original geometric figure. We're going to call that the pre-image onto a new figure. We're going to call that the image. We're going to change its position, size, shape of a figure. Okay, so just some keywords to kind of go over here. So the transformation, that's what all of chapter 9 is going to cover, different transformations. We're manipulating shapes in different ways. Okay, two vocab words here are going to be pre-image and image. The pre-image is what comes first. The image is going to be the new image, what comes second, or third or fourth if we do more than just two things. Okay, so for now, getting started, we're just going to have two. The way we're going to be able to tell them apart, okay, looking at our figures, and we're mostly going to use triangles just because it's the easiest shape to use because it's only got 3 points, but you might have a few quadrilaterals in the mix. Okay, I can tell which one came first because of the way it is labeled, right? So our original figure here is labeled triangle ABC, if I go in order. Okay, and the new figure here, you see those little dash marks next to the letters? We're going to call those primes. So this is A prime, B prime, C prime. Okay, and then if we, get later on into the unit, those like a third image sometimes, and they're going to have a double prime, right? So then you'll be able to look at the image and know which one came first, which one came second, which one came third, so on and so forth. If they get real crazy, you can have triple primes, quadruple primes, all that. But like I said, for today, we're just going to stick with the first two, right? The original figure and the new figure with just the prime. All right, so isometry, another vocab word, not as crucial as the other vocab word, so it's not in bold, but it's still a vocab word that we're going to go over, is where the pre-image is moved and the position is changed, but the two images remain congruent. They're the same shape, same size. All we did is reorient it. Okay, so the first 3 transformations we're going to learn are all isometric, meaning it doesn't change the shape, it just moves it. Okay, and there's only 4 total, so the 4th one we'll get into later in chapter 9 as well. Okay, so the first 3 are reflection, where we're going to flip it, translation, where we're going to slide it, and rotation, where we're going to take it and we're going to turn it. Okay, today we're mostly going to focus on reflection. Okay, but then as we move on into chapter 9, the next ones that we're going to go over are going to be our translation and our rotation. Okay, I'm talking a lot. It's a lot to take in, so just stay with me. All right, so now diving into reflection. All right, so reflection is where we're going to take our image and we're going to flip it. Okay, it's kind of like a mirror image, so we've got that line that we're going to flip it over. That's kind of where the mirror is. We're going to call that our line of reflection. Okay, I like to go in and label them on all my images too, just to point out what it is, LOR for line of reflection, just so we know where it is and what purpose it's serving. Okay, just like a mirror, guys, the distance from the line of reflection or from the mirror is going to be the same either way, right? So imagine if you're looking in a mirror, you put your hand up on the mirror, it's going to look like you're giving yourself a high five, right? Because the reflection of your hand is going to be right there. As you pull your hand away from the mirror, the image mirrored from your hand is also going to get further away. So it's going to get further away in both directions. So it's going to look like it's the same distance both ways. So here, that kind of follows the same idea. So when you have your point on the line of reflection, for example here, point A is on the line of reflection. Well, when we reflect it, point A prime is going to be right on top of it, right? That's you giving yourself a high five on the mirror. Okay, now let's say point A is further away from your line of reflection. Here it's 2 spaces. Then point A prime is going to be exactly 2 spaces away from the mirror in the opposite direction. Follow me? Make sense so far? Okay, well now that we've got kind of that understanding and background of it, let's see what it looks like in a problem. All right, so when we're doing problems for this, here they've given us a triangle. JPQ has vertices and it gives us the coordinates for J, P, and Q. We all know how to read coordinates. The first number is which way, which movement? Right, up, down, or left and right? Left, right, right? The X is left and right. And then the second number is how we're moving up or down. Okay, so if it's positive for X, which way are we moving? Right. And if it's negative for x, we're moving left. Positive for y, we're moving up. Negative for y, we're moving down, right? We've learned that before. We know that, right? It's not anything new for us. Okay, so here we have our line of reflection, and it's drawn for us. Not always. Sometimes it just tells us where it's at, and we're going to have to go draw it ourselves. I always like to make sure I identify it and label it. Okay, and they even gave us the pre-image, right? What the image that came first, they want us to graph the new image, right? Or the image. Okay, so it's being reflected over the line x equals -1. So if we go from the origin, which is right here, I always mark my origin with a little O. X equals -1 means we're moving to the left 1, and then that's where we draw our line. So if we move to the left 1, we draw our line straight up and down from there. Okay, so now reflecting it, we're going to use the picture to help us out with these ones. Okay, same rule. They're the same distance from the line. So if J is right here and it is 3 spaces away from the line of reflection, the mirror, that means J prime is going to be 3 spaces away in the opposite direction. So I'm going to put my J prime right here. And make sure you label your points. They always have to have a name so we know where they came from and where they ended up. So that's our J prime. Okay, Q is right here on the line. So when I reflect Q, where's Q prime going to be? Right there, right on top of it. So Q and Q prime are actually in the same spot. They're just on top of each other. Okay, and then P is 4 spaces away. So we're going to go 4 spaces in the opposite direction for our P prime. And then once we've got our 3 points plotted, go ahead and connect them the best you can. Again, guys, this is not art class, so I'm not judging your shape drawings. As long as I can tell you put the points in the right spot and you understand what it's supposed to look like, we're good. Okay, so now that we have our image, okay, looking at it, we can see the triangles. They didn't change shape or size. All it did was flip over that line. It looks like that. That means we did good. Now we're going to go ahead and list the coordinates. So we've got to read the coordinates. So J prime, located here, counting from the origin, we have to move to the right 2 and then up 4. So the coordinates for J prime are going to be 2, 4. And then going again for P prime. P prime's located right here. We got to move to the right 3, up 1. So that's going to be located at 3, 1. And hopefully this doesn't feel crazy new to us because we've learned this stuff before. And then what about Q, or Q prime, I should say. What do we say for Q prime's coordinates? We go left 1 and then up 1. So what do I list for its coordinates? -1 and then 1, right? And we said Q prime is the same spot that Q was. We see here that Q was also located at -1, 1, and we know it didn't move. Okay, so those are the same. All right, how are we doing so far? So far, so good? We got it? All right, let's do another one. What if my line of reflection goes through my shape? Well, what happens then? Okay, so let's walk through it and see what it looks like when we reflect it. So everything above my line of reflection is going to get flipped below, and everything below it is going to get flipped above. So the image is going to look like it's just flipped on top of itself. All right, so just taking it each point by point, J is 2 spaces above my line of reflection. So J prime is going to be 2 spaces below. We're going to go the opposite direction. So there's J prime. But Q was located 1 space below, so where's Q prime going to go? 1 space above. Same thing with P. It's 1 space below, so P prime is going to go 1 space above. And then we connect those 3 dots. I usually like to do these in different colors too because it gets a little bit easier to see. And then we can see there's the black triangle and then that blue triangle. It's the same triangle, it's just flipped upside down, but they're right on top of each other. So that's what happens when we've got our line of reflection going through our shape. And then here they're just asking what were the coordinates of J prime. So reading it from the origin, so the origin is here. We're going left 4 and we didn't go up and down at all. So what are those coordinates? We went left 4, and then we didn't go up and down. So one of them is going to be 0. Is that the first number or the second number? The second number is 0 because it doesn't go up or down. But we went left 4, so that's a positive or negative 4? Negative. So we got negative 4, comma, 0 to get J prime's location. All right, good? Next, reflecting over the x-axis and the y-axis. So these are like our mirrors that are commonly used, so they have their own special rule. So we don't even necessarily need the picture every time we're solving them. Okay, so the y-axis, or I'm sorry, the x-axis, when we're flipping over the x-axis, the y coordinate is the one that changes. So if that's my line of reflection, the rule here is x comma y will become x comma negative y. So the number isn't going to change, but the sign is going to change. Okay, so we'll see here for point B. B was originally located at 7 comma 3. So B prime is going to be located at 7 comma negative 3, right? So not a whole lot of math or counting and stuff involved. We just need to know the rule. Oh, the 3 is just going to change to a negative 3. Everything else stays the same. And we'll do that with all of our points when we know we're reflecting over the x-axis. Okay, very similarly, the y-axis, when it is our line of reflection, right? So we got our line of reflection here. When we're flipping over the y-axis, the x-coordinate is the only one that changes. So x comma y becomes negative x comma y. And that means if it's negative, it turns positive. If it's positive, it turns negative, okay? So point A here is located at 2 comma 3. So when we flip it over the y-axis, it's negative 2 comma 3. Again, nothing else changes other than the first number changes signs. So simple rule that we can remember. That way we're not having to count squares, especially when we start dealing with bigger numbers. All right, so practicing what that looks like. First example, we've got a triangle JPD. It gives us the coordinates for J, P, and D. Write the coordinates of the reflection over the x-axis. So this time, we're going to solve it using the rule rather than counting boxes from the picture. So the rule is x comma y changes to what? If we're flipping it over the x-axis, who changes? The x or the y? The y. So x comma y is going to become x comma negative y. So the first number is going to stay the same, but the second number is going to change. All right, so looking at J, right here I've got negative 3, 0. So for J prime, we're going to put negative 3, 0, right? So 0 changes, but 0, there's no such thing as negative 0, it's still 0. So that one's just going to stay the same. All right, and then here for P, we have 0, comma, negative 4. First number stays 0. Second number, negative 4, is now positive 4. So 0, comma, positive 4. And then our last one, D, located at negative 5, negative 2. First number stays negative 5. Second number becomes positive 2. All right, does this look familiar, ring a bell, or it's not terribly complicated? Good? Okay, so now that we have our new coordinates, let's go put them on our picture and make our picture look pretty. Okay, this is our line of reflection. Again, it's not always given to you. I know in the notes it's going to be given to you, but it's not always given to you, so make sure you draw it. That way you know where it's at, so we don't get turned backwards or whatever. Okay, so J prime was in the same spot. It didn't move. Makes sense because it's right there on the line. P prime is at 0, 4. So we're not going to move left or right at all, but we're going to move up 4. So it goes up here. Looks good. And then D prime is at negative 5, positive 2. So D prime is going to land right up there. We connect those dots. And then we take a step back and look at our picture and we say, they look the same, it just got flipped. That means we did it correct. All right, the next one, we're starting with the same triangle, the JPD from the problem we just did, but this time we're reflecting it over the y-axis. So this is our line of reflection. So the rule changes, x comma y, instead of it being the other way, what's changing now? So instead of the y changing, this time we have the x changing. So it's going to be negative x comma y. Okay, good news here is you don't have to memorize all these rules, guys. You'll be given a table that has the rules, but we do need to understand how to read the table so that it can be helpful for us. Okay, so don't stress about having to memorize these, but you'll have a reference for them. Okay, so now, this time, the x coordinate is the one that's going to change. The y coordinate here is the one that's going to stay the same. So with j located at -3, 0, what's j prime going to be? The first number changes, the second number stays the same. Okay, so the first one will be a +3, and then the second number stays the same. Second number is a 0, so it's still going to be 0. All right? For the next one, p is located at 0, -4. What's p prime going to be? Caleb, what you got? What happens when we try to change 0? We don't, right? It's just 0, so it still stays 0. And the second number is not going to change, so that's going to stay -4. All right, and then the last one, -5, -2. +5, -2. Very good. Okay, so now we've got our new coordinates. Let's go put it in our picture. Okay, 3, 0, starting at the origin. Label the origin if it's hard for you to find it. It's right there. Okay, 3, 0, right 3. It's going to go right there. Make sure we label it, j prime. P prime is 0, -4. So we're not going to go left or right. We're going to go straight down. It lands right on top of P. That makes sense because it didn't move. And then D prime, 5, -2 is right over here. Connect our dots. And we just flipped our picture over the y-axis. Bless you. Okay, we feel okay with these? Not too bad? All right, I got 2 more. I know it's a lot of talking today for me. Stay with me. Let's look at the next one. Okay, 2 more common nears, right? These ones also come up. Again, the rules will be given to you in a table, but we've got to understand what they mean. All right, so another common line of reflection is the line y equals x. So that is going to be a perfectly diagonal line that has a slope of +1. Okay, so when you're drawing it on the graph, like if you have a graph where the origin's perfectly in the middle, you're just connecting the 2 opposite corners with a positive slope. Okay, we reflect over this line a lot. The rule for this one is x comma y will become y comma x. So the numbers aren't changing at all, they're just trading places. Okay, so for example, if b is originally located at -1, 4, trade places. B prime is at 4, -1. Okay, easy rule. Especially hard to count boxes because you're counting boxes in 2 directions, so the rule is actually faster with this one. All right, and then the other common line is going to be the same thing but flipped, so it's a slope of -1. So this is when y equals -x. The rule is x comma y becomes -y comma -x. So they trade places and they change signs. Okay, so looking at point C, it's originally 1, 4. C prime, we're going to flip them and change their signs. It's going to be -4, -1. That one I think is as tricky as it gets with the reflection. Okay, and again, the rule will be given to you, so shouldn't be too hard. Just try to pay attention and not rush through those ones. All right, so let's practice it. This one, they stepped it up and gave us a quadrilateral instead of a triangle, but it's just 1 extra point. I also like that they set it up this way because it makes it a little bit easier to solve it. They have us put the rule first, they give us the coordinates, and then we give them the new coordinates. So this one, we're reflecting it over the line y equals x. So that's the positive slope line of reflection. So the rule was x comma y becomes what? It's right above. They switch places, so it's going to be y comma x. All right, so working through that, if m is at 1, -2, m prime is going to be where? -2, 1. Perfect. All right, and then we can just go down the list and flip all of them, right? This one's at 2, -3, so s prime is going to be at -3, 2. They're just trading places. Again, n is at 4, negative 2, so n prime, negative 2, 4. Very good. And then last one, w is located at 4, comma 1, so then w prime is at 1, 4. We have our coordinates, we go plot them on the graph, okay? So if this is my origin right here, I got negative 2, 1, so I'm going to go left 2, up 1. That is my m prime. Negative 3, 2, so I'm going to go left 3, up 2. That is my s prime. Negative 2, 4, we go left 2, up 4. That's my n prime. And then last, 1, 4, we're going to go right 1 and then up 4. We land right there. That is our w prime. And make sure we're connecting our dots in the appropriate order. And then when we sit back and look at it, we should see it's a perfect reflection of the first image over the line. Good? All right, one more, and then we'll get to something a little bit more interesting. Okay, this time we're reflecting it over the line. Y equals negative x. So our line of reflection is the perfect negative slope of negative 1. The rule, x comma y becomes, they flip and change. So it's going to be negative y comma negative x. All right, so looking at them carefully, the first one is located at negative 5 comma negative 1. Bryson, where's our y prime going to be? So flip the two numbers and then change their signs. Yeah, so since it was a negative 5 first and a negative 1 second, so now it's going to be the, there you go, positive 1 first and then positive 5, right? So 1 will be before 5, and since they were both negative, now they're both positive. We see what we did? Okay, because we're doing two things. So this is, like I said, this is the part where it gets a little tricky. All right, so then let's try it again with this one. We got negative 2 comma negative 4. Julius? Positive 4, positive 2. Very good. And then our last one, we've got a negative 3 comma 0. Derek?
0, 3.
He says 0, 3. The only one that doesn't really ever change is 0 because there's no positive or negative 0. And that was the hard part. Now that we have our coordinates, we just go put them in the picture and make sure it looks right. Okay, so our origin is right here. We said y prime is located at 1, 5. So we're going to go right 1 and then up 5. So it's going to land right there. Make sure you label it, y prime. W prime is at 4, 2. So we're going to go right 4, up 2. W prime goes right there. And then J prime is located at 0, 3. So we don't go left or right at all, but we're going to go up 3. And it lands right there. Connect those dots. And then sit back and look at the picture and make sure it looks right. Does it look right? Perfect. Beautiful. All right. All right, like, shake it out, guys. Wake up. We're almost done. All right, so that's all of 9.1. I'm going to do a little bit of 9.5 today, which is kind of my favorite part of the notes. So next page, I'm just squeezing it in just because it is similar to what we're talking about. But I like this one a bit more. Okay, so reflectional symmetry. Since we're talking about reflection, we're already thinking, you know, mirrors and stuff like that. 9.5 is all about symmetry. So reflectional symmetry, what do you think when you hear the word symmetry? If something's symmetric, it's what? It's the same, it's balanced, right? On both sides. Like if you have a symmetric face, that means your face looks the same on the right side and the left side. Okay, so reflectional symmetry or line of symmetry is when a figure can be mapped onto itself. The kindergarten way that I like to explain this, imagine we're cutting this shape out. Okay, so this shape, it was on paste paper, I got some scissors and I cut it out and I'm holding that shape in my hand. Can I fold it in half in a way where everything lines up onto itself and I don't have any extra pieces sticking out? Okay, so yes, and I would fold it in half along that line that they gave me. Okay, and visually, right, our brains understand that this point would match up with this point right here would match up with this point right here. This edge would match up with this edge, right? And I wouldn't have anything sticking out. Okay, so with these questions, they're very simple to answer. It says, state whether the object appears to have reflectional symmetry, aka can it be folded in half? Right, yes or no? If so, draw all the lines of symmetry, aka draw the lines where you would fold it. Okay, and then state their number. So the question there is asking, once you fold it in half, can you unfold it and fold it in half another way and still have everything line up? Well, with this shape, we couldn't have, right? Because it only lines up that one way. So now we're going to go through a series of images and see how many different ways can we fold it perfectly in half. All right, so this first one, Mr. Krabs, can he be folded in half?
Yes.
Yes. How would you fold him? Right, straight down the middle. So we would say yes. I'd fold him this way. Okay, can I unfold him and fold him any other way?
Yes.
How? Not really, right? Because if I folded him down, those claws, there's no claws down here to match up with that, so it wouldn't work. Okay, so we're going to say yes, but we can only fold him one way. All right, and then our next one, Patrick the Star. Can we fold him in half? No? Yes? How would you fold him?
Same way we did the crab.
Right, straight down the middle, so like this. Okay, because this point here would match up with this point here, this point would match up with this point, and then this half would match up with this half, right? So that's good. Let me erase my little markings here. So that's one line of symmetry. Can I unfold him and fold him again in another way?
Yeah.
Yeah? Which way?
You just
Do it for each of his legs, right? Because starfish, as long as they don't have any mutations or anything, for the most part, are pretty symmetrical. So it'd look like that, right? Those are all the different ways we can fold them. So our answer is yes. Okay, now here, this is where some of my students, not all my students struggle, but some of my students struggle with counting the lines. Okay, and I do this too, because I'm going to look at this and I'm like, okay, how many different lines did I just draw? And I'm like, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we know that's not right. We're going to just draw 10 lines. We're counting lines twice.
divide by two.
So that's one strategy, just divide it by 2. Okay. Another strategy, you're not wrong. Another strategy that I've done is when I'm counting my lines, I'll put the number on both ends of it so I know not to count that line twice. So that's my first line. This is my second line. This is my third line, fourth line, fifth line. So how many lines of symmetry does this guy have? 5, which makes sense because it's a starfish and it's got 5 points, right? 5 legs. So there's our starfish. All right, next one doesn't have a cute SpongeBob type name, but it does have a name, and we learned how to name these shapes. Not just a polygon. What do we call it? How many sides does it have? 6. So we call it a hexagon. Yes, very good. Okay, so this hexagon, can we fold it in half? Yes. How would you fold it in half? Straight down the middle? Okay, so we can go like that. Can I unfold it and fold it again somehow? Which way? Sideways, straight across. Good. Any others? The angles, right? So if I just connected a corner to a corner, I can do that with all the corners, right? Connect it with the corner across. So this corner can connect with that one. So I'll draw the line there. And then the other 2 corners can connect. So we got those. Any more? The first line we drew didn't hit a corner. It went from
On each side.
a midpoint to a midpoint, right? So this is a midpoint of a side and this is a midpoint of a side. So we can do that with the other sides that don't have a line, right? So midpoint to midpoint there, midpoint to midpoint there. Okay, we got lots of lines. Let's count them. We got 6, and it was a hexagon. A hexagon has 6 sides, so makes sense a little bit that we would be able to fold it 6 different ways. All right, we're okay with this? Like I said, this one's the easier part. The beginning of the notes, I know it was long. There was a lot of talking through it, but For the most part, it's stuff we've seen before from middle school, and it's just a refresher. All right, so this is no notes. This is actually the table I was telling you about. So on the day of the test, you'll get a sheet of paper that's going to have this table on it. So we need to understand how to read it. Okay, the type of reflection. These are the 4 common ones. Okay, first one being the x-axis, x comma y becomes x comma negative y. The y-axis, x comma y becomes negative x comma y. When we flip it over the line y equals x, that's where they trade places. So x comma y becomes y comma x. And then the tricky one, when we're reflecting it over the line y equals negative x comma y becomes negative y comma negative x. So this is your little cheat sheet. You'll have this right now. Highlight it, put stars around it, because this is where you have it, is in your notes, because you get to use your notes on your exit tickets and your classworks and all that stuff. But the day of the test, I will give you a sheet that will have this on it. Whew. Bueno? Any questions? Y'all ready for the exit ticket? Okay, so I'm going to give you the exit ticket, and then I'm going to show you guys, I'm going to help you get started on the exit ticket as well, because there's a lot of drawing on it and stuff, just to make sure that we understand. All right, here we go.